The aircrafts have been fueled by jet fuel produced from the petroleum sector. The sector is looking to decarbonize, and SAF can contribute to about 65% of the sector decarbonization.
What is SAF?
Sustainable aviation fuels, often called as renewable or alternate jet fuel, is sustainably produced from a range of renewable feedstocks and technologies. It can be blended with or replace fossil-based jet fuel to reduce life cycle emissions and aid in decarbonization in the aviation sector. Technip Energies has extensive experience and is uniquely positioned across all the SAF production pathways, executing projects across the globe. Technip Energies is involved in various capacities in over 6 million tons of built or under engineering SAF capacity. Let's use some project references to discuss the 4 main pathways to SAF. The Neste projects in Singapore and Rotterdam use what is called the HEFA pathway, or hydroprocessed esters and fatty acids. This is the most commonly used pathway today and converts used cooking oil and animal fats into high-quality fuels through hydrotreating and hydroisomerization. It is less complex and produces the least expensive SAF, but feedstock availability is limiting new capacity. Our Jet Zero Australia and LanzaTech Dragon project, UK, deploys alcohol-to-jet, or ATJ technology that converts bioethanol derived from waste off gases, CO2 or biomass to SAF. This technology, licensed by LanzaJet, uses Technip Energies' Hummingbird technology as the first step to dehydrate the ethanol to ethylene, followed by the LanzaJet technology to oligomerize the alcohols into SAF and biodiesel. The world's first commercial ATJ plant in Georgia, the Freedom Pines unit, was recently started up based on our technology. Next, we can talk about the Sky Energy Pacific Northwest project in the US that deploys the 3rd pathway, gasification Fischer-Tropsch, or GFT. Biomass or waste feedstock is first gasified to form CO2 and green hydrogen, which is converted to a syngas stream through a process called RWGS, or reverse water gas shift. This syngas, a mixture of CO and H2, is then sent through a catalytic reactor system to upgrade the syngas to longer hydrocarbon chains, thus producing SAF along with biodiesel and bio-naphtha. And finally, the most complex and sustainable pathway, power-to-liquids or PTL or e-fuels being used at the Arcadia e-fuels project in Denmark. The PTL process converts green H2, generated using water and renewable energy through electrolysis, and CO2 from the atmosphere or other emission sources all the way up to SAF. Once CO2 and green H2 are available, syngas, CO and H2, is produced, as described in the previous pathway, which is then upgraded using the Fischer-Tropsch process to SAF, biodiesel, and bio-naphtha. The landscape may be slightly more complex when you look at all the permutations to produce SAF, including multiple pathways currently under ASTM certification, such as methanol to SAF. However, the ones described are the most mature and being adopted today. Technip Energies is flying high in the SAF domain and is well-positioned to be the global leader in sustainable aviation fuel across the technology pathways and cater to the needs to achieve the ambitious SAF targets.